This is a Raspberry Pi 4. It's a new model of the Raspberry Pi. It's got a 1.2 gigahertz processor, 4 gigabytes of RAM on board. It has gigabit Ethernet. It's got 4 USB ports. It's got dual 4K HDMI video output. I have a camera plugged into it right now. And I also have this ribbon cable, which allows me to connect to the general purpose input-output, or GPIO pins. And that's coming over here to this prototype board with a Raspberry Pi cobbler, or a connection, so that I can plug wires in, and those are connected over here to the Raspberry Pi. Right now, what I did to test the Raspberry Pi and my brand new oscilloscope that I just got yesterday is I wrote a program up here in Python, and this program is running on the Raspberry Pi. And what it does is it generates a pulse width modulated output signal. So I have a signal that's with a frequency of 50 hertz, so it's outputting 50 cycles per second. And the duration of the pulse that its output is varying from about 600 microseconds up to 2200 microseconds. So this program I wrote in Python to test the output, the general purpose I/O pins on the Raspberry Pi. And what I'll do is I'll close this program and then run it so you can see the output on the oscilloscope. So I do a :Q, and that will close the program. Now I'm going to run the program. So this will start the program. And now we can see it's controlling a servo motor. So the pulse width modulated output, the pulse widths are designed for the servo motor. And you can see the signal, the pulse width is varying on the oscilloscope. So it's max 2200 microseconds down to about 600 microseconds. And this is a 4-channel Siglent SDS1104X-E oscilloscope. It's very nice. I paid about $490 for it, and I just got it yesterday. So I'm testing different operations on it. It has a built-in serial decoder, so you can send serial communications in different formats, and it will decode the communications and generate the text or numbers that you're sending over it. One nice feature on this oscilloscope is that it has a built-in web server. Oh, we can't forget the cup of coffee here too. We need that. But it has a built-in web server, so I can come over here on my PC, and I've got the browser opened up to the IP address on the oscilloscope so that we can see the entire oscilloscope on the monitor, and we can control everything. So I can vary, for example, the horizontal time base, so I'll change it, and you can see how it's showing a shorter signal now because I changed the time base. And I'll go back to the longer time base here. I can change the vertical scale. So right there it's at 2 volts per division. And right there is at 1 volt per division. And you can see it's going 1, 2, 3 divisions up. So it's about 3 volts on the PWM voltage signal. And it's sweeping back and forth. So it's a very nice setup. The new oscilloscope is awesome. And it has a USB connection. It also has the ability to plug in a digital 16-channel digital connection, so you can do data acquisition on digital circuits also with it. So that's my awesome new setup. Thank you.